So let's take a deeper step into each of these functions in our ETL process. So we have mapping and managing metadata, capture, extract, scrub or clean our data, transform the data, and then load and index the data. So for mapping and metadata management, this is a design step. Really, a lot of this takes place, what I would say, on paper. It's really a good idea for us to make graphical representations of how our data might be connected. And a good way of doing that is you might have tables with the data that is in the origin, and you might have, multiple origins. So that'd be origin number one, and let's say that's origin number two, and so on and so forth. And then we have our destination, and what we're going to say is that we're going to pull data from here and load that into the destination, and then another one from here. So this is a whole idea about mapping our data. So it identifies our data sources, it recognizes the same data that might be in different systems, and then it gives us some steps on how we're going to be able to connect those pieces, right? This is typically a big planning process of the ETL job. So the next step is we're going to capture that data. So after we create the whole map, imagine that this over here is your data source. We're actually going to go into this idea about capturing all that data. And what's going to happen is that we're going to create a small database inside our ETL process here. And this is where we're always going to manage our metadata, right? And the reason why that we're looking at it from this perspective is that metadata repository is really a good idea, or it has the senses of as to where we want to go across each of these steps. So our first step is this capture extract step, and this is when we extract all of the data from those additional databases. So there's two ways that we can do an extraction. We can do what's called a static extract, which basically captures source data at a single point in time, right? So we could say everything that is in here, let's go ahead and pull it all out and then start to extract it. Now another thing we can do is what's called an incremental extract. So let's say that we've already extracted everything at the beginning, and we put a date stamp on when we extracted the first time. And then we're going to only look for the changes that occurred after that time date stamp. And we're only going to now extract those changes, and that's what's called an incremental change, right? So the capture extract option is basically capturing that snapshot of the source data for loading into our data warehouse. Right. It's important to understand too, it's a snapshot, and sometimes that snapshot might be all the data or just pieces of the data. So capturing extract, as we have already talked about, it's that snapshot. It can either be all at a single point in time or since the last static extract. All right. The next step is the scrub cleanse option, right? This can use different techniques, including pattern recognition and artificial intelligence, to upgrade the quality of our data, right? So this can help us fix errors, like misspellings, erroneous dates, incorrect fields, etc. Also, we can decode some of the data, convert it, add new calculations. Also, we can put some error correction in or error detection in our process. So we can fix the errors that we find, of course. Then we have to create ETL process steps to be able to detect those errors and fix them as appropriate. Scrubbing means that we look for pattern recognition. A good example of pattern recognition is that if you had a single field that might show like the state and the city. So let's just say it would be Boone, North Carolina, and another one might be Charlotte, North Carolina, right? And these were all single fields, and we wanted to split this up into city and state And we can use pattern recognition, recognizing the North Carolina preceded by a space to be able to help split those up. So this is a way of scrubbing our data to be able to upgrade the quality, and upgrading means that now we've taken what was previously one field and split it into two. All right, so it helps with preventing defects. It also increases our data standards and creates some continuous improvement efforts. Now, transforming will allow us to join some data, aggregate data, select specific portions of our data. And I was using scrub and cleanse to talk about changing things from single field to multi-field. And these can, move into different types of examples. So that transformation process takes data in its raw form and now starts to make what we would consider to be new pieces of information. So here are some basic transformation functions that will be applied during this process. So here's what we call the record level transformation functions. These are things that happen per record. And what we mean by record is one row in a database. So we may decide to select specific data on a given criteria. So if we have a data table that has multiple rows, and in our problem example, we're looking at data that we're only looking for machines that do injection molding. So those would be selected data rows that we would pull from, and that is part of that selection process. So then joining is the process of combining data from various sources. So if you have one table that has, let's say, a foreign key for the country, and then you have another table of country that has the primary key, we might decide to join these tables and just say what the country is instead of putting the IDs in. Aggregation would be a matter of what I would call removing some granularity. So it would go from detail to a summary level type of data. So for example, in what we're dealing with in our class project, is that we have data that is based on a batch, and that batch has taken up multiple rows in our data source. And instead, what we've done is we said, all right, well, we're going to go ahead and combine all those single rows of data into one row and then summarize the total being produced. Right, so this aggregates all of those rows together. So it's a summary of that single batch. And then the normalization process is the idea that we produce smaller and well-structured relational data. But sometimes with our data warehouses, we get into a denormalization process. But that would be something that we would do at the record level, right? Another level, what we call the field level. So we're not looking at how to make changes to the record. What we're doing is we're looking at the field. And if you remember in our databases, the horizontal are records. Well, like say that the vertical is a field, and a field is something like the name of a person, their address, city, state, and so on. So here are a couple examples where we can do some transformations at the field level, changing from Fahrenheit to Celsius. Maybe we have a 2-letter state code and we want it the full name. So here, if it was AL, we would transform it to Alabama. If it was NC, we would transform it to North Carolina, and so on and so forth. Here's some other field level transformations. We might have a source that has the employee name and the telephone, and in our data warehouse, we want to combine their name and their telephone number and then make that the employee ID, right? Or another way is that we might have a product code that includes something like the brand name and then the product, but it's in one field, like a Ford Pinto. And then what we'll do through a transformation is we'll split that, the brand, Ford, and the product would be the Pinto. Ford Ranger, etc., etc. All right. So we'll get into the load process here in the next video.